Even veteran aerospace experts, when they first saw images of the Raptor 3 engine, could only shake their heads and say, "This engine looks incomplete." But then, the unthinkable happened. Elon Musk officially pulled back the curtain, revealing a mechanical marvel that left NASA scientists stunned. Raptor 3 isn't just a new engine, it's a quantum leap in the quest to conquer space. It's lighter, more powerful, and believe it or not, doesn't even need a heat shield. You might be wondering, how did they eliminate the thermal protection system, something absolutely critical in the extreme temperatures of rocket engines? Stick around to the end, because today's episode of Space Now will take you straight to the heart of the most jaw-dropping upgrade SpaceX has ever pulled off. With a single upgrade, Raptor 3 shed over 2,200 pounds, yet delivers up to 730,000 pounds of thrust, a figure that seems to defy the laws of physics. Remember the chief engineer who once doubted this design? SpaceX silenced all criticism with a test fire so powerful it stunned the entire aerospace industry. So, what makes Raptor 3 the key to getting humans to Mars, building a moon base, and reusing rockets thousands of times? Buckle up, you're about to witness a whole new chapter in the space race. On May 29, 2025, Elon Musk officially unveiled a series of major upgrades to the Raptor 3, the primary engine for the Starship rocket. And it's no exaggeration to say this marks a turning point in the era of rapid reusability. With over 300 successful tests and a total of 16,000 seconds of burn time, nearly 4.5 hours of continuous operation, Raptor 3 is now ready to propel Starship to low Earth orbit, the Moon, and even Mars. Now, let's talk about the one thing that made military engineers tip their hats: weight reduction. Raptor 3 weighs approximately 3,362 pounds, about 7% lighter than the Raptor 2, which weighed in at 3,593 pounds. But the most impressive part: when you count the entire system from the engine to all attached hardware, Raptor 3 comes in at just around 3,792 pounds, cutting more than 2,400 pounds compared to Raptor 2. In aerospace, shaving off even a single pound is a battle. So how did they do it? The answer lies in one bold decision: completely eliminating the heat shield at the engine base. Sounds insane, right? But Elon Musk explained, if there's a fuel leak, the fuel simply mixes with the burning plasma without causing any issues. No need for auxiliary fire suppression, no added weight, and no extra failure points. Auxiliary circuits and pipelines have also been integrated directly into the engine body, saving space and improving durability in extreme environments. What do you think of that solution? Simple engineering or a daring risk? The benefits of this design go beyond just weight reduction. It allows Starship to carry up to 88,000 pounds more cargo to orbit. This isn't science fiction anymore. Starship is turning humanity's limits into history. Welcome to Space Now. Just imagine 88,000 pounds of additional satellites equipment, or even building materials for a moon base. This is a strategic breakthrough in the way we think about space logistics, especially in the context of a potential military space campaign. If you were a logistics officer, how would you make use of those 40 extra tons? But don't think of Raptor 3 as some overnight miracle. On the contrary, it was built on the solid foundation laid by Raptor 2. SpaceX didn't cut corners. They learned from every test, refined every detail, and improved step by step. Raptor 2 was already a radical redesign, trimming unnecessary parts, replacing bolted joints with welds, simplifying the plumbing and eliminating redundant ignition components. The result? A lighter, stronger, and more manufacturable machine. Raptor 3 is the next chapter where every lesson learned has been elevated to a strategic level. From a military standpoint, it embodies the principles of rapid response, low cost, and high-efficiency core traits any future Space Force would demand. So here's the question. If Raptor 3 were adapted for a military version of Starship, could we be witnessing the birth of an interplanetary weapons transport? The changes in Raptor 3 weren't random. They're the inevitable result of hard-earned lessons through both success and failure with Raptor 2. This is the essence of SpaceX's engineering philosophy: always learning, always improving, and never compromising on performance or reliability. If engineering were a military campaign, then Raptor 3 would be the precision counterattack executed after countless scouting missions tests and post-battle assessments. Sound familiar? It mirrors the evolutionary spiral strategy often seen in advanced weapons development, not reckless leaps, but deliberate data-driven upgrades. SpaceX chose the sustainable path, refining each element from fuel flow lines to circuit layouts, all grounded in real-world data, not theoretical assumptions. The ultimate goal: to make Starship as reusable as a commercial airliner, with each engine capable of flying 1,000 missions with virtually no major maintenance in between. Just imagine no more disassembling engines and checking every bolt after every launch. What do you think? Will we one day be able to book a seat to orbit as easily as we book a flight to New York? NASA once had doubts. Experts once laughed. Until Raptor 3 lit up the test stand. You're watching Space Now, where the truth speaks louder than the rumors. Of course, not everyone believed in Raptor 3 from the beginning. When SpaceX first released images of the engine, ULA CEO Tory Bruno publicly questioned its design. The engine looks unfinished, missing control systems, plumbing, and thrust vectoring components. At first glance, it made sense, but this was exactly the point. SpaceX had streamlined everything, eliminating excess, integrating every system into a compact, lightweight, and high-performance mechanical core. In military terms, this is the gold standard for hardware design: minimalist yet fully capable. Not one to stay silent, SpaceX President Gwynne Shotwell released the first test-fire image of the Raptor 3, shattering all doubts. The photo showed the engine firing flawlessly, despite looking anything but complete, as Tory Bruno had claimed. Then Elon Musk responded on X with a single word: LOL. But behind that laugh was an incredibly complex engineering system. Every pipe wire and support component had been tucked into the engine's main structure because Raptor 3 doesn't have a heat shield. That meant every single part had to be actively cooled, even areas where no fluid or airflow naturally passes. This is the pinnacle of internalized engineering, where everything must not only function efficiently, but survive in a hellish thermal environment. And SpaceX doesn't just talk the talk, they back it up with real-world data. In August 2024, Raptor 3 hit 280 metric tons of thrust, a 21% increase over Raptor 2, despite being 7% lighter at just 362 pounds. And Elon made it clear they're not done yet. The team is aiming to break 300 metric tons, possibly even reach 330 in the near future. You heard that right, 703,000 pounds of thrust from a reusable engine, a number that many experts once called physically impossible. Is this the rocket engine world's sound barrier moment? On X, Raptor 3 is being hailed as a true breakthrough in propulsion technology, and that's not an exaggeration. With Raptor 3, SpaceX is setting a new standard. Reusable engines are no longer a futuristic idea buried in NASA white papers. They're a present-day reality. The entire aerospace industry is watching, from private companies to defense organizations. Because they understand one thing clearly: Raptor 3 isn't just an engine. It's a technological declaration of the next era. Imagine a future where spacecraft launch as smoothly as commercial airliners. That's no longer fantasy. It's starting to take shape right now through Raptor 3. So, what do you think? Could this be the engine that finally makes space a familiar frontier for humankind? Leave a comment below. We'd love to hear your thoughts, especially if you come from an aerospace defense or engineering background. If you found this content valuable, don't forget to like, subscribe, and turn on notifications because I've got plenty more hot space updates waiting for you to explore. Keep dreaming big and looking up, because Starship isn't just a rocket. It's humanity's boldest declaration to the universe. We're not stopping at Earth. Elon Musk's wild dream Starship isn't just a Mars ship. It's a multi-mission transport vehicle designed to carry both crew and cargo to Earth, orbit the Moon, Mars, and far beyond. So what makes it so special? This is officially the most powerful launch vehicle ever built, fully reusable, capable of delivering up to 330,000 pounds of cargo into orbit. That's mind-blowing. And if it's a one-way mission, Starship can haul over 550,000 pounds, enough for 100 passengers on months-long interplanetary journeys. But let's zoom out. Starship isn't just built for Mars. It's designed to handle a wide range of missions: satellite deployment, moon base construction, or even ultra-fast global travel. Can you imagine flying from New York to Tokyo in under an hour? Still, the real game-changer might just be orbital refueling, a technology that could flip the strategic script in today's space race. And Starship's refueling method, incredibly smart and shockingly simple. A tanker version of Starship, nearly identical to the main ship, but without windows, launches to low Earth orbit and waits. Then the primary Starship docks and refuels. This enables it to carry up to 200 to 20,000 pounds of cargo to Mars, a feat virtually impossible with traditional rocket designs. And since the tankers are reusable, the fuel, just liquid oxygen and methane, becomes almost negligible in cost. From a military strategy perspective, this is the space-age equivalent of aerial refueling a mobile depot in orbit, reshaping the logistics of conflict in zero gravity. But the journey doesn't end there. Future models, Starship version 2 and 3, are already in the pipeline, aiming to push performance into entirely new territory. Still, there's one undeniable obstacle: cost. Dreaming of Mars is one thing, but if each launch costs hundreds of millions of dollars, that dream risks getting shelved. So how does SpaceX plan to flip the equation? The answer sounds simple, but it's incredibly bold: mass production. Elon Musk didn't study aerospace, he studied automotive engineering. And now he's applying car assembly line principles to rocket manufacturing. The goal: to produce multiple Starships every week and drive the cost down to around $10 million per vehicle, something unprecedented in spaceflight history. This vision rests on two critical pillars: full reusability of both rocket stages and radically reduced turnaround time between launches. But Starship isn't just reusable like an aircraft, it's edging closer to commercial airline-level operational efficiency, a dream that past programs like the Space Shuttle never fully achieved. A larger payload means the cost per kilogram to orbit drops dramatically. A higher launch cadence spreads out fixed costs more effectively. One design, many missions, building moon bases, launching satellites, even carrying space tourists. So if NASA's Space Shuttle was once a symbol, then Starship may become the first truly effective and scalable version of that vision. Do you agree? Here's one way to look at it. Falcon 9 was just the warm-up. Starship is the leap. With the capacity to carry 330,000 pounds to orbit, Starship dwarfs Falcon 9's 50,000-pound limit. That increased lift capacity doesn't just reduce the number of launches, it boosts logistical efficiency, and lowers costs across the board from commercial satellites to military payloads. Once SpaceX fields a full fleet of Starships and super-heavy boosters, they won't just be launching rockets. They'll be rewriting the very logic of the space industry. The long-term vision to make leaving Earth as routine as catching a flight. And NASA isn't sitting this out. In 2021, the agency awarded SpaceX a $2.9 billion contract to develop a specialized version of Starship called the Human Landing System HLS for the Artemis program. It's a central piece of NASA's plan to return humans to the Moon by mid-2027. Starship's mission is no small task. It will carry astronauts from lunar orbit down to the Moon's surface, performing the first crewed landing since Apollo 17 in 1972. But it's more than just a ride. Starship HLS will also transport equipment cargo and must function reliably at the Moon's south pole, a region believed to contain vast reserves of water ice beneath the surface. This is a strategic resource not just for producing water and oxygen for astronauts, but also for creating fuel for deeper space missions, including Mars. With a payload capacity of 330,000 pounds and full reusability, Starship becomes the ideal vehicle for expanding human presence on the Moon. What do you think? Could we soon see a permanent lunar base acting as the forward outpost for humanity? Despite the challenges, including some recent testing failures, SpaceX remains committed to its development roadmap: build, test, iterate, and improve. It's the core of Elon Musk's test to learn philosophy, mirroring how the U.S. military refines weapon systems through hundreds of live combat simulations. Instead of avoiding failure, they use it as fuel to move faster, stronger, and more resilient. That's why Starship isn't just a rocket. It's a blueprint for the future. If SpaceX succeeds, this isn't just about landing on the Moon or building a station on Mars. We'll be entering an entirely new era where space becomes a playground for science, commerce, exploration. And maybe one day for you. And this is just the beginning. Space Now will continue taking you further beyond the Moon, beyond Mars, and into the vast unknown. So, are you ready to come along? Don't forget to subscribe and turn on the notification bell so you never miss an update from SpaceX and the world of space exploration right here on Space Now.